by the way, I have one question for you. Okay, so you know that K. Shashank is going to Japan. So he is going from Delhi to Japan. In midway, he found that he forgot something in H40. So now he is jumping from plane, and he has parachute as well. Okay, he has parachute as well. Now he is jumping, and now he is landing to H40. In mid way, he opens the parachute, and some velocity will change, and so on. So how can we draw the graph, velocity versus time graph for this whole jump?
Okay, so like in order to understand the velocity versus time graph, and I'm assuming there is
Yeah, we are absolutely considering air resistance.
air resistance was there and the inhibitor, right? So initially, let's say Shashank falls from the air, right? Now initially there is a gravity acting on it, right? So now because of the gravity or the gravitational acceleration, which I assume there is a constant gravitational acceleration, right? So the velocity will increase linearly with the time. Right? But now because of this air drag, there is an opposite force acting on that Shashank. Now that force will depend on two factors. The first is what is the magnitude of that velocity, and the second is what is the surface area. Now because the Shashank has a very low surface area, so initially there is a very low force acting on it. Now as the velocity will increase, the drag force also increase. Now there is a competition between these two forces. Right? So there is a time came where the net acceleration becomes zero, the velocity becomes zero.
Oh, that terminal velocity.
Right. And that is called the terminal velocity. So now when from time t equal to 0, the velocity will increase, and the time, after some time, the velocity becomes constant. Now at some moment in time, we will open up the parachute, right? So now when the parachute will open, there is a very large surface area of parachute. Now because of that, there is a very large drag force with that, right? So because of drag force, now the acceleration, the gravity is still there, right? But now because of their acceleration, the velocity will drop, suddenly drop.
Oh, that curve.
But it's still, there is still velocity, there is still drag force. Now there is still this competition was there. Now there is also after some amount of time, the velocity will again become constant. Now that constant velocity is lower than the initial constant velocity. The second terminal velocity will be lower than the initial terminal velocity. And then after some time we will land safely on the ground. So here's the Shashank.
He's coming from that plane.